Hello and welcome to the Extended Greg YouTube channel. I'm Greg, and on today's show, we're going to be taking a look at users. We're going to be programming some users on the Alpine Linux installation that we have on our Raspberry Pi. So let's get right into it. So pretty much what we have is the standard installation that we did the last time around, where we actually went through, or if you want to check out that video, I have it on VOD. So be sure to check that out. But it's the installation of Alpine Linux on Raspberry Pi. So what we're going to be doing today is we're going to be adding a new user, and then we're going to be doing some things with the home directory, things of that nature, just to try and make everything persistent. So the way that we currently have our volume set is that we have it so it automatically resets to the last saved state every time that we reboot. The issue with that, of course, is if you have users on the system, they're not actually going to be able to save any files. Or if they do, they're going to get blown away if the system restarts for some reason. So we want to make sure that it's actually able to persist through those reboots as well. But that, in addition to also setting up SSH for being able to log in using a public-private key authentication method, instead of using a password, which is a bit more secure for production purposes. So we'll kind of touch on that and just do a quick example. We're just going to stay local to the machine just for the purposes of simplicity. But at some point in the future, we'll do another video where we'll get into some of the networking and things like that in terms of how to lock down the box, especially if it's like on a web service somewhere. So getting right into it, the easiest way to add a user is just to use the command add user. All right, and then we're going to name our user new user. It's going to ask us to set a password. I'm just going to set a very secure password. And I'm going to confirm it. It's going to do it anyway. It did warn that it was too weak just because, in this case, this is not a production system. But we've now effectively created our user. So if we wanted to change that password, so let's say we wanted to set up a bunch of user accounts, things like that, have them all have the same password, but then be able to change it later, we can then use PASSWD, short for password, and then the username. In our case, it's new user. It will, because we're root, it won't ask us to confirm the old password. If we were logged in and we weren't logged in as a root user, it would ask us to confirm the current password first. But in this case, it's just asking us for the new password. I'm going to use another very secure password. And it says that it's been changed successfully by root. Excellent. So now let's set up the SSH login. Now there's two ways to do this. One way is that we can actually go through and log in as the user. So we can go through and pretty much log in as the user using the password, and from there generate the key there. But let's say we were on a machine and we wanted to just generate the key itself. We can actually just use keygen. In this particular case, I'm not going to use it with flags, because if you had an actual private key already set for your root user, this particular command would overwrite it. But it's just to kind of get our feet wet. When we go into a more detailed explanation of how to lock down a system, we'll do it differently then, or at least a variation of this. So just to keep it simple, it's SSH-keygen. And what this is going to do is it's going to generate a matched set of keys. So it's going to be a private key as well as a public key. So what I did is I saved it to the default, which is just saving it in a hidden directory. It's going to ask us for a passphrase for the file, same thing again, and then we see some nice little image art that it creates as a function of that. But the way that SSH works is that it's going to have the public key actually inside of the machine that you're connecting to, because technically you're going to add that potentially to multiple machines. And then your private key will be on your your private key will be on your individual user terminal that you're using to connect into it. So you'd keep your private key with you, your public key with the server. So there's an easy way to actually get it there. So in this particular case, we just have it as idrsa.pub, which, okay, we can look at that really quick. So if we cat this, we see it's not particularly long, and it says the user at the end. It says it's root at test Alpine, but that's actually just a reference line. So at the end of the day, we can actually copy this so it can be used for another user as well if we wanted to do so. The keys just have to match each other. So it just tells you who generated it. So the way that we're going to do that is we're going to use SSH copy ID. And I'm going to clear the screen just to make it a little easier. SSH copy ID. All right, and then we're going to do the actual user that we want to install it for, in this case, new user. And then @ symbol, and we're going to do the IP address or domain name of the machine that we want to connect into. In this case, it's going to be the local host because we just created the user here. So we're going to do it. It's saying that where the source of the key is, and then it's saying that we've never connected through SSH to this machine before. Do we want to trust the fingerprint? So as far as verifying that the server is who you think it is, because again, IP addresses can be assigned arbitrarily, if you remember through our the networking video we did, that we don't necessarily know who this is. So if it doesn't recognize it, if it hasn't connected to it before, it will prompt and ask. So in this case, we know that this is us. So we're going to type yes. So that's going to add it also to a list. So if we connect to it subsequently in the future, it will remember our answer. Now it's going to ask for our username or the password for our new user. And that does have a window. And then it says number of keys added is 1. Now we can try logging into the machine using the command SSH new user at 127.0.0.1. So we can log in using that, but we're going to specify the specific IDRSA file, just because you don't necessarily have it in, the same place every time. If you're on a Linux box, yes, you'll have it, but if you're on a different box, you may not. So the command for that is SSH-I, and I stands for identity file. And in this case, we have it in the SSH folder. We could do the full path. Actually, I'll do the full path. And that's where we have it. And the two files that we have are id_rsa and id_rsa.pub. The one without the extension is the private key. And that's the one that you keep secret and safe for yourself. Then we would do the username, in this case, new user, and then @ symbol, and then the IP address of the server that we're connecting to. You see that we get the welcome prompt again. And we want to actually verify that we're logged in who we think we're logged in as. So we're going to use the command who am I, okay, all one word. And it's going to tell us that we're logged in as new user. So it's a good way to check, especially if you're going from a Linux box to another Linux box. If you want to make sure that you're logged in as the right person before you're making changes. Otherwise, you could be changing your own account and not realize it. So who am I is the way to do that, and it says we're logged in as a new user. So let's go ahead and create a file. So we're just going to touch a file, and we're going to call it new user-testfile.txt. Right, and we see that it's new user, it exists, we haven't added any content to it, then that's fine. We don't have to add any content for the purposes of this example. And if we wanted to see where this file was located, we could do pwd for present working directory, and that will tell us that we're in /home/new user. And that's stored on our local drive, but it's a temporary drive. So if we were to restart the machine now, we would lose that file. So because we're logged in through SSH, and we've logged in through SSH, so we're 2 SSH sessions deep The easy way to get out of it is to just type exit. And now we see that our connection, our SSH connection that we were doing locally from root user to test user is closed. And we can verify that by, again, doing who am I? And now we see we're back to root. So now that we've done that, if we had a situation where we needed to lock down the SSH server itself, we can actually block it so user passwords cannot be used to authenticate. And this is good for production purposes, and we're not going to actually set this here because I still need it. But in this particular case, if we did want to change that, we can edit /etc/ssh/sshd_config. And what we see here are a number of values that are pretty much available for us to change to be able to change the behavior of the SSH service. And something that we set when we initially configured and ran setup Alpine is we allowed for permit root login, yes. So we see that there. We keep scrolling down, things like that. We have these two options right here. So do we want to allow clear text passwords? And we would actually delete the hashtag at the beginning, and we would change this to no. And what that will do is it will force the user to use the key, or it won't allow them to log in at all. It's a very good way to avoid easy access for hackers, because then instead of having to guess, potentially a 8 to 12 digit or letter and number password, now they would have to guess hundreds of characters of private key in order to do that. And what that means is that the complexity associated with that task is more than any computer currently can actually do within a person's lifetime. So is it impossible? Technically not. Is it improbable? Highly. It's considered secure. So that's a best practice if you are going to use RSA authentication. It doesn't expire those particular certificates unless you change one side without changing the other. So just something to keep in mind. But we're not going to change that here for now. So I'm actually going to quit out of this using qbang, as they call it, in order to pretty much disregard those changes. So once we actually set that, we could restart the service using rc service and then sshd restart. If I type it correctly, it restarts. So pretty much from there, everything is pretty stock. If from this point, if we did lbu commit, it would save that user, and that user would persist through reboots, as well as the IDRSA key, things of that nature. So pretty much from there, we'd be able to go ahead and use everything as normal. So, that's one option, but there's a problem with that. And that is the user can't save any files without them being blown away, because especially with the default user installation, they're not actually going to be able to do any commits on their own. So they're not going to have the permissions of root to be able to do it. So one way we can give that to them is to install the sudo package. So if we do apk add sudo, what that will do is it will allow us to run the sudo command when we're logged in as new user to be able to do that. So one of my cats. So pretty much we'll be able to use the sudo command, and that's able to emulate the root user. So if we wanted to do that, we would have to change the users group to be able to be a part of a group that is allowed to use sudo, because by default, it will not be able to. So when you create a new user, what you will have is it will be the username, in this case, new user, and a group name of the same name, in that case, new user. So in order to get it to add to the group that's by default available to sudo, you would have to add it to a group called wheel. So we could do group add, and I believe, and actually I'm doing this off script because I want to talk about it, but let me just verify. There it is. Okay, so it's add group, excuse me. On some systems, it's group add, depending on which package you have. If you've used Ubuntu, you know both exist. But in this particular case on Alpine, it is add group. So we would do add group, the name of the user, and then the group, which would be wheel. Simple as that. And then the user can then, once they log in again, will be able to use the sudo command preceding any other command like sudo lbu commit to be able to save changes and do other things that are normally reserved for just root users. So I'm going to actually remove the sudo package just because it does cause some other problems, and I think it's just going to be easier. But I just wanted to point that out, that that does exist. So another way that we could do this is that we can actually move the user account to another directory that, let's say, we don't have, or that's on another drive or something else like that. So let's kind of go through exactly some of those steps at first, and then we'll actually do it by moving it to a USB thumb drive that we have plugged into our Raspberry Pi. So we're going to add a package first, and it's apk add shadow. And what this will do is it will add a command called usermod, which will allow us to change users' home directories. So first, let's make the directory. So we'll do make dir, and then we'll do -p, and then we'll do new home / new user. And what -p does for make directory is it will create the parent folders if they do not exist. So that way you don't have to go through and type the command for each folder level. It will just do it all at once. So if we ls into our root directory, we see that new home now exists right down here. And I notice this is not set to catch my mouse. So let's see, well, yeah, you can see me highlighting it. So that right there. So from there, we would then want to move all of the files or copy them from the original home directory to our new home directory for that user. Because obviously, if they have files in there already, we'd want to preserve those. So we would do cp /home / new user star, right? And then we do another space, and we do the path to our destination, which is new home, new user. And now if we ls into new home, we see our new user test file exists. Great, so we're ready to actually change the user's home directory to that. So we're going to do usermod -d for directory. new home, new user, and then the name of the user, which is new user. And actually, I believe it doesn't need that slash at the end if we don't want to add it. So now we've changed that directory, the default directory for that user. And this is the same directory that we logged into initially. You know, when you first come up, it comes up to a prompt with the tilde, just like we have here. And pretty much what that is your home directory. So that's what we're changing here. But we want to make sure they have read and write access to permissions to it because they won't necessarily be able to change it. So we want to change the ownership. And that will give them full access permissions to anything in their home directory. So we will change it to new user, new user. And what that will do is it will change both the username, which is the first new user, and the group assignment, which is new user, to both be for that user. So that way they're pretty much the same. They own everything. So everything within that folder. Specify that. And that's what the capital -R is. It's recursive, so if they have folders, subfolders in there, things like that, it will also apply to those as well. But we're just resetting these permissions. Excuse me. And we're going to apply that to new home / new user. Right, with no slash in particular at the end here. Because if you put the slash, it will do everything within that folder. If you don't do the slash, it will do that parent folder as well, that folder as well. So we hit enter. Now it's applied. We can actually check that by doing ls-l. And actually, let's do LA. So -L will give you file permissions. A will give you everything, including hidden folders. So we'll do -LA. That way we see all of that. And we'll do new home. And let's see what we got. So we see that the parent folder, new home itself, is owned by root, which means new user won't be able to modify anything within that. So if we put other users' directories in there, they would be safe. They wouldn't be able to be modified by new user. But new users folder is owned by new user. That way they can modify anything within that. And we can also verify this another way and verify that the actual change to set the user's home directory has applied by doing greep. And we're going to search, and greep is just a search function. But new user, and we're going to do /etc/passwd, which is where that information is stored. It's an actual file. And when we look, we see user, new user, with the ID 1000, has a home directory of new home, new user. And we actually see that it's also using the interpreter bin ash as the default interpreter. Other options would be bash or sh. So, but that's just some information that we get. But greep returns the line that contains a file, or that contains, excuse me, the keyword that was entered for the search. So now we've done this, but the problem is, of course, in this particular case, new home is still on the same drive that's write protected. That's not going to actually preserve through reboots. So that's a bit of an issue. So let's actually go through, and I have a USB drive that's installed. It's brand new. It's just a simple 32 gig drive, USB 3. And in this case, I'm using a Raspberry Pi 3, 3B plus. So at the end of the day, it's only going to be connecting at USB 2 speeds anyway. But if you're just saving text files, things like that, it's easy enough to, it's not going to affect performance that significantly. So, if you had a Raspberry Pi 4, you would have USB 3 available. You could put in a USB thumb drive, or you could actually hook up like an NVMe through a USB adapter and be able to use that as a second hard drive. So, and there are ways to do this through partitioning as well. So you can set up a partition that's protected and then have a second partition that's actually writable. That way you're not affecting your base OS installation. But that's a bit outside of the scope. So this is still using the original the original method that we used for the installation. So to format the drive, first let's find it. So we're going to do fdisk-l. And what we see here, we have two drives, okay? We have this drive up here, which is our MMC BLK, so multimedia card, block 0, P1, partition 1. Oh, I see why you can't see it. It's because it's inverted. Okay, so, and then down here, we have /dev/SDA1. That's our USB thumb drive. So that's the one that we're going to be modifying from here on out. And we see that it's currently formatted for Windows, FAT32, and it is 28.9 gigs in size. Okay, that's great to know. So let's go down and let's go ahead and format it. We're going to make it the ext4 format, which is a native Linux partition format, instead of it being a FAT32. And that allows saving over files over 4 gigabytes, things of that nature. So it integrates a lot better with Linux. So let's do makefs .ext4. And then we're going to insert the path that we just got, which is /dev/SDA1. So it says makefs not found because we haven't installed it. And just if you watched, I believe, one of the basics videos, I did cover how to search for this, but we're going to do it now again. Just so abk search, and then we're just going to type in the command that we're missing. And the actual program that we want to install is e2fs progs, and just apk that in. And in this case, I copied it, so I'm just going to right click and paste it. Just updating my notes. So it's installed it successfully. So now if we run that same command again with the makefs.ext4, it says it already contains a file system labeled USB disk. Do we want to proceed? In this case, we know that there's nothing on there, so we're going to type yes. So now it's actually going to format the drive. It's going to take a second because it comes up with create super blocks, journaling, things like that to kind of prevent issues. And it is pretty resilient in terms of if there's problems, it's able to recover from them. So it's a good file system. And in a lot of ways, it's a lot better than FAT32, which is quite a bit older. But in this case, we just got to wait for it to finish. Yeah, and unfortunately with this, there's no quick format option. So if we were doing this on Windows with FAT32, we could do a quick format, things like that. But because of the way that this actually does it, there's no way to expedite this any faster than it already is. So it's completed formatting the disk. So we can actually do the fdisk-l again, and -l is just for list. Right, and we see doesn't look like there's any change, but actually it is changed. So, and you'll see when we mount it, we don't have to put any additional flags, things like that. So first thing we're going to do is we're going to make a directory to actually put it in. So when we mount things in Linux, we actually, instead of giving them drive letters that we would on Windows or anything else like that, we would give them actual folder paths. So the folder path that we're going to use for this is /mount /USB drive. So we've created that folder inside of mount. Mount already exists by default. It's one of the default directories. And then what we're going to do is, since it's empty, we actually want to add it to LBU. Otherwise, it's not going to persist through reboots. And that would cause an issue with a later step that I'll tell you about. But we're going to do LBU add /mount /USB drive. Then, in order to make sure that we don't care about anything that's actually in it, because it's a separate hard drive. So if we were to mount the drive, for example, and then run LBU, if we didn't do this next command, which is LBU exclude /mount /USB drive, it would think that we actually want to save everything in our persistent image, and it would cause problems with mounting it in the future. So we want to make sure to exclude everything inside of that folder. So we're only saving that outside folder itself, just so we can maintain that mount point. So if we do LBU commit at this point, it will save that, and we'll always see USB drive appear every time as an empty folder. But what we can do with that empty folder is we can mount our USB drive. So we'll do /mount /dev /SDA1, and then /mount /USB drive. I think I said that wrong a second ago, but I typed it correctly, USB drive. So pretty much we're mounting the physical device to the folder location. So we'd enter, and it's mounted. We can verify that by doing df-h. And what we see at the very bottom here is we have our drive mounted in mount USB drive, and we see it has 26.8 gigs available, and it's currently has 2 megabytes used, so it's pretty much empty. And we can ls that, and we can do ls-la, and then the actual path, which is mount USB drive, and we see it has a lost and found, which is something that's, if there's problems with files, things like that, it will actually drop it in that folder. But then there's, nothing else in there. So pretty much it's our base formatted drive. So from here, now let's say we actually want to move over our user's files again. And I'm going to show you a different way to do it. So we're going to do apk add rsync. And rsync is a very good tool because what it's able to do is it's able to compare the source and the destination directories and be able to move the files across that haven't been moved or haven't fully been moved. So it's a great way to verify that everything has been moved successfully, especially if you have major hierarchies, things like that, that you actually need to transition. So let's do rsync. And then we're going to do the flag AV. And I'm not going to go into what it is too much, but -A is archive, V is verbose. And then we're going to do our source directory, /home /new user, which is our original home directory path, which we didn't modify. And then we're going to do /mount /USB drive, which is our destination. All right, and we see all of the files that it has actually transferred. And it says that the speed up is less than 1, just because it's kind of slow, and it transferred at 2 kilobytes a second, because honestly, it was a lot of very small files. So we ran it once. If we run it again, we'll see that it didn't actually transfer anything because it transferred it successfully the first time. So there's nothing left to transfer. So if you get to the point where you're running it and nothing's happening, then you know that everything has been transferred successfully. Or if the user made changes, things like that, it would actually account for that and it would transfer those files. But once it starts showing up blank, then everything is transferred. So it's a very good tool for doing transfers where you need to be absolutely sure that everything copies successfully. So now let's look at our folder. So mount, USB drive, and we see that there's a new folder in there called new user. And we see our original text files there. And if we do -LA, we see it has all of our other files in there as well. So we've successfully copied all of the files over. So now we're ready to be able to proceed. So the next thing that we want to do is we actually want to make it so the drive automatically mounts on boot. The way that we're going to do that is we're going to modify the etc fstab file. And what this does is this actually contains all of our definitions for all of the drives that we actually want to be able to put, automatically mount on the system. So we're going to insert a new line, and we're going to put the path to our device. And something I will say is here you see where it says UUID for the actual root. It's actually a good practice to be able to use that, because if we plug in multiple devices, if something comes up as a higher priority, it could try and wedge itself in front of the USB drive that you actually intend. But if you're never going to modify or add any additional drives, it will probably work forever. So keep that in mind. But the UUID is actually unique to each individual physical device. So what we're going to do is give it the destination. So I'm going to hit the tab key just to keep everything in line. We're going to put that folder that we just created. Then we're going to tell it is ext4 file type. We're going to say we're going to want to mount it with defaults. Then we're going to do /0 /0. Right, and that's it. So we'll save that out. And then we're going to test it. The way that we test it, because if we try and reboot, we could actually lock ourselves out of the system if it's not able to access it. So we'll do mount -A, and that will mount everything that's in the fstab folder. Right, it is there, but I think we had it mounted before. So to unmount it, we're going to do umount, and then the path to the folder that it is mounted at. So now if we run it again, we see it is not mounted. And if we mount it again using mount -A, we see it is now mounted again. So it is working as we expect. So it should work when we do a reboot. So next, we actually need to set the user's home directory to be this new directory. So we're going to do usermod, once again, -D, and we're going to do /mount /USB drive, new user, and we're not going to put a slash at the end, space new user. Okay, and we're going to chown everything that's inside of the directory, just like we did before. And we can verify this by doing the greep command. And we see that it is, in fact, updated to that new path. Perfect. So now we can commit this. So let's do lbu commit. I'm doing the -D just so it cleans up. But lbu commit. And now we can actually verify it. So let's SSH back into it. So we'll do SSH-I. And it logged us right in. It didn't have to ask us to verify that everything was there, and it took a second because it actually had to come up with the encryption in order to facilitate the connection. So now we can verify that we are logged in as who we think we are, and who am I reveals that it's new user. We can do ls-la, and we see that all of our stuff is there. Our new user test file is there. We can do pwd, and we see that we're currently reading and writing to and from our USB thumb drive. And we can even create a new file. So we'll touch a new file and say this is a new file. When we ls-la again, we see that it is there. We own it. We created it at now. And pretty much from there, everything is great. So now if we reboot, we can actually see and verify that that file exists successfully after the reboot. And you see, this is what I was talking about with the sudo command. So because we're logged in as test Alpine, reboot requires, because it could affect multiple users potentially, requires sudo permissions, or at least the ability to log and run commands as root. So to do that, we're just going to exit our shell right here, and we'll reboot. See, now we're back to root, and we'll reboot from here. So it's going to reboot. The actual terminal disconnected. We're going to give it a second here in order to fully come back up. And we will log in and make sure that we can actually see the file that we created without running the commit, indicating that it is saving successfully to the USB drive. It's exciting stuff. If you guys have, if you like the video, be sure to hit the like button and all of that. Share this with your friends. It definitely helps me out. I'm trying to grow the channel. So I definitely appreciate you watching. If you've made it this far as well, double thank you. So let's see if it's come back up. So I'm just going to restart the session. It's asking who I want to log in as, and I'm just going to log in as test user directly. Now, I don't have the IDRSA key on my computer because you have to do a conversion in order to get to PuTTY, and I thought that was a bit too far out of scope for today. Oh, wait, I might need to log in as root anyway. So it will only let us log in with the key. So I got to log in as root first. And then we have to SSH into it. And just to confirm before I do that, so if we do df-h, we do see that it has automatically mounted after the reboot. So we'll do sh-i, and I think we still have it. Actually, I should verify that. We don't have the IDRSA because we didn't add it to LBU, but you see how frustrating this can be if you have your home directory on a non-persistent volume. So we're just going to log in with the password, but if we did have it, it would have preserved that, or if we added it to LBU, it would have saved with it. It didn't save the fingerprint either because, again, we didn't add that to LBU. By default, /root is not one of the directories that's actually a part of LBU. So now if we do who am I, we see that we're currently logged in as new user, so it preserved the actual user settings. If we do pwd, we see that it's on the USB drive, and if we ls-la into the folder, we see this is a new file is preserved. So it did preserve everything that we wanted to on a separate volume from our OS drive while still maintaining protection and keeping the rest of the operating system embedded. So that pretty much does it for today. So thanks for watching the video. If you like the video, be sure to hit that like button and leave a comment down below. Share it with a friend, everything else like that. If you haven't subscribed, please subscribe. It helps me out a lot. And then hit that notification bell. That way you know the next time we're getting extended. So until then, take care.